Hey guys, welcome back. In this lesson we're going to take a look at data matching in Grasshopper, another aspect that is very important to understand. Any component with two or more inputs will apply this technique if the input streams are of different lengths. Unfortunately, it is a problem without a clean solution. I'm going to show this using a very familiar example you've probably seen before, and that is connecting two lists of points with different lengths with line segments. So let's get started. We're going to draw two lines for this in Rhino using the polyline command. And let's draw them also different lengths. Nice. So now I'm going to link those two curves into Grasshopper using the curve component. So that's one and the other one. Now I'm going to use a component that divides this curve in a set of points we specify. And that component is located under the Curve tab, under Division, and the component is named Divide Curve. Now the default is set to 10 segments, which means we have 11 points. But I want to control this manually, so let's insert a slider, a number slider. And let's set it to integers, and let's set the maximum to 20. Let's copy it over so we can independently control the divisions for the both curves. Now if I connect a line between those 2 points by inserting a line component, you see that right now there's no problem because both inputs for the line component have the same length. They both contain 11 points for the A and also 11 points for the B. But what if I change the length for one input stream, let's say the A, if I switch this number to 15 for instance, you see something weird has happened in Rhino. You see that up until point 11 the lines got connected nicely, but after that point you see that the rest all got connected to the last point of the B stream. Now this is called data matching. Now this happens when a component has two or more inputs, like I explained in the beginning, and the inputs have different lengths. Grasshopper tries to match to the best of its abilities to combine the input data and produce a proper output. In our case, a line segment. Now there's some nice components that we can manipulate how this data matching happens. And those components are located again under the Sets tab, under List. Those are the last 3 components in this tab: cross-reference, longest list, and shortest list. So let's insert them all 3. Now let's start with the longest and shortest list, which are these 2. And let me delete this line component, because we're going to insert one of these components in the middle. And as you can see, they also have an A and a B input, but if you zoom in, you can actually add more inputs if you'd like. In our case, you only have 2 inputs, the A and the B, so we can remove the inputs. And now let's connect our line component again to the A and B output. Now, if you right-click on this component, you see that it has different options. It has trim start, trim end, and interpolate. its default is set to trim end, and as you can see right now in the Rhino canvas, it has stopped after point 11. Because one list is longer than the other one, so it will basically stop at the last point of the shortest list. And that's exactly what trim end means. Now if I switch this one to trim start, you see that it basically flipped it around. Instead of trimming the end, it will trim the start of the longest list. Now the last option is interpolate, and this is a really interesting one. This option will try to interpolate between the two lists and try to find the best matching pairs, let's say. And as you can see in our Rhino canvas, you see that it sometimes skipped a point. And that's exactly what the interpolate means. So if I add some more points or remove some points, you see that it tries to match up really nicely. Now let's take a look at the other one, which is the longest list. And also let's copy this line component over. And let's turn this component off. If you middle mouse click on the component, you get this submenu where you can have some shortcuts. I use this menu a lot to enable or disable components or turn their preview off. This setting is the same as the one if we just connected a line component directly to the 2 point outputs, which is repeat last, which is its default. If I do repeat first, it will do it the opposite. Instead of repeating the last point, it will repeat the first. The amount of times the list is longer than the other one. Now if I switch this one to interpolate, it will do the same as the shortest list component, but it will actually connect those points also to the same point. Wrap means it will continue connecting the longest list with the values that start with the shortest list. As you can see here, after point 11, point 12 on the other list doesn't exist in the shortest list. That's why it went to point 0 again, all the way in the start. And the last option is flip. And this means it counted backwards. So instead of starting at index 0, then index 1 and 2, it started counting backwards. So you reached index 11, and then it connected again to index 10, index 9, etc. Now you may ask, what if I wanted to connect all the points holistically? Well, there's the other component I also inserted, which is the cross-reference component, which does exactly that. So let's connect our points to that one, and let's also connect our line component to that component. Let's turn off this component. You see that now every point got connected with all the other points. So you have a lot of different connections. Now the nice thing is of the cross-reference component is that it has a lot of options as well. And I'm going to go over those, because they can also be very helpful to you if you want to combine and cross-reference certain sets of data with each other. I'm going to use a different example for that to make it a little bit more clear. So let me copy this component over and let me disconnect the inputs. And I'm going to use a panel for that with some text. So let's say A, B, and C. And let me set this list to multi-line data, so all the items have their own index. Nice. So we're going to use a small component in the middle, which is going to combine these two strings together into one string. And there's a nice component called concatenate, which does exactly that. Now if I insert a panel to see the result. There's nothing left because we still have to connect our first panels. So as you can see with the line from the line example, you see that now with letters it's a little bit better to see. You see that all combinations got combined together. So we have A with A, then BA, CA, etc. And then it goes to the next one, which is the B, and then it also combines those holistically together. Now, the nice thing of this cross-reference is, like I mentioned, is that it has some other options. Let's say if we set it to diagonal, this means it will exclude from the two input lists, it will exclude the indexes that are the same. So in our case, it will not combine the A with the other A, the B with the B, and the C with the C. As you can see in our final list, those two, they got excluded. Now, you might ask, why is this helpful? Let's say if you want to find the intersection between a certain set of B-reps, for instance, or a certain set of curves. Let me show that quickly to you. So let's copy this component over, and let's kill the inputs. Now let me also switch this component off. Let's go to Rhino, to perspective, and let me quickly draw some B-reps, some cubes, some simple cubes. And let me copy them over a couple of times. We move them up a little bit and down. Something like this. Just as an example. Now let's say you want to find the intersections between all of those cubes. Now the trick is to not find double intersections, that first of all, they don't intersect with themselves. You just want them to intersect with all the other cubes. And the second rule, if you find an intersection, let's say with cube A with cube B, you don't want also cube B to find the same intersection with cube A, because then you would have duplicate lines, as we will see in a second. And this component can do all of that, which is very handy. So let me link in all the B-reps using a simple B-rep component. Now let me connect them to the A and to the B. And let me first set it to holistic, so we see the result. And let me insert the component which is under the intersect tab, and it's simply called B-rep with B-rep intersection. Now let me turn these components off. Let me hide them. Also, let me turn off the points from our previous example. So now we did, like with the point and lines example, we intersected everything with everything. And as you can see, also the cubes got intersected with themselves. That's why you see the outlines of the cubes. Let me insert a preview component to preview the geometry a little bit better. And a swatch for the color. Let me set it to transparent. Something like that. So we don't want that, like we said. Now let's take a look at the next option, which is diagonal. And this is the one I mentioned in the letters example, that it excludes the intersection with an item in the other list with the same index in front. So now as you can see, we're already there, because now it excluded the intersecting with itself, which is really nice. Now we have only the intersections with other cubes. But the thing is that if I bake this outcome, so let's select this component, go to solution and select bake selected, or hit the insert key, turn off this component. Now if I select one line, you see that it's duplicated. Now, like I mentioned previously, is that we have duplicate lines because if one cube intersects with the other cube, you have an intersection. But of course, if it gets to the other cube and it intersects again with the previous one, you get another intersection line. That's why all the lines, they are duplicated. Now, the nice thing is that if we delete the lines, and if you go back to our example, there's the other options, which is coincident, which is basically the same as diagonal. The only thing is that if you have multiple inputs, let's say, but for now we can neglect that because we only have an A and a B input, but let's say if you have a C input, coincident will become a little bit more relevant. The next one is lower triangle. Now the nice thing about this one is that it will include again the diagonal, but the nice thing is that it will exclude double intersections. So if I bake these lines, you see that now there's only one line segment, let's say. If a cube intersected with another cube, it will not happen again for the other one, let's say. So which is really nice. But the only thing is that right now it intersected again with itself. So we need to take a look at the last option, which is the lower triangle strict. And that will also exclude the diagonal option. So let me delete all the lines. And right now, this is the one that is helpful for us. So this one will actually intersect all the cubes and only have the intersection line only once, so no duplicate lines. So if I bake this line by hitting insert, you see that it's only one line, no duplicate lines. So this can be very helpful if you want to find the intersection between a lot of different types of geometry. For curves, luckily there's a component right now, which is located here, which is called, let me check. It's called multiple curves. And this component does exactly that. It's basically, if I would have to duplicate for the same thing, you can basically copy paste this component . So this would be all your curves. You want to check for intersections. If I group this part, these three components will do the same as this component by finding the intersections. Now if we go back to our B-reps, the last two options, upper triangle and upper triangle strict, do basically the same as the lower triangle and lower triangle strict. The only thing is that it will flip the list around. So instead of checking from the start and which items to neglect from one list for repeating, it will actually start from the end of the list. So this brings us to the end of this lesson. I hope these three components can be helpful for you to kind of manage lists a little bit in a better way and also to understand data matching a little bit better. In the next lesson, we're going to take a look at some series and sequence components and how we can manipulate lists and data using those components. I'll see you in the next lesson.